Hi, this is Steve Hosher with RazorGage, and this video is about the AutoList screen. To get to the screen, you go from the main screen of the RazorGage and click the AutoList button. Now the AutoList screen is the functionality we have for opening cut lists, optimizing, sorting material cut lists into groups, and you can use it as a stop, you can use it as a pusher, it works in automatic mode, it's got a lot of functionality. Now I'm going to go through and try to hit the highlights here. Now the first thing I'm going to do is open a file. Now the first file I'm going to open would be the kind of file that would be opened by a cabinet shop. So I'm going to click Open File. Now you can navigate wherever you want to find the file. This one is going to open up this file. Now when it opens up, it displays the part groups. Now this is new functionality. If you have a slightly older RazorGage, this video is being made in February of 2014. It didn't used to pop up with the part groups immediately. You used to have to click grouping list to get this, but we changed it so that immediately upon opening a file, it shows you the groups that the part cut list has been sorted into, so you can choose a group right off the bat. I'm going to choose this 4/4 red oak, and here's the list. Now what happens when we open a file is the RazorGage software sorts the cut list into groups, and that is what we saw when I first clicked Open File, and you can see it again by clicking Grouping List. So what does it mean that we sort it into groups? Well, if you have a cut list that has many types of material, for example, and you want to optimize the best use of your material across a certain material type, to do that, we have to sort the material into groups, or the cut list into groups of like material. So that's what we're doing here. Now you can tell from this listing that here we're sorting by material and width. Quantity and length are always shown in this screen. These two fields show what we are sorting by. So we're sorting by material and width. Now why not thickness? Well, in this case, material is 4/4 red oak. This software, or the software that created this cut list, listed the material with the thickness as part of the material description. Therefore, we don't have to be sorting by thickness as well as material and width, because thickness is part of the description. Down here you can see 1/4 red oak ply. What that does is each of these material types is the same, but they don't reference width. So we have 4/4 red oak that's 2 inches wide and 4/4 red oak that's 3 inches wide. If we didn't sort by width, then these parts that were made of this material would be lumped together. So I'm going to just demonstrate that because it's important to understand the sorting. So to do that, I'm going to go to Settings and click Sorting, and now I'm going to remove width from the sorting criteria, and I'm going to update the stock definition and then go back here. And now notice that under the width column, these are the parts that are in the group 4/4 red oak. I'm going to go to the grouping list so you can see that now we only have 1, 2, 3, 4, 5, 6, 7 groups, because all the parts that are made of 4/4 red oak are together, and 5/8 Luan, and so on and so forth. But you'll notice that we have 3-inch red oak and 2-inch red oak, and there may be other widths. There's 2 3/4, 1 1/2. So you see, that wouldn't be good, because if we're going to optimize, you have a piece of material and you want to make the best use out of that material, we have to be looking at parts that are made of that kind of material, or else we aren't going to get the results you're looking for. So now I'm going to go back to Settings and Sorting and add width back into it, update the criteria, and now all our widths in this group will be the same. But if I go to grouping list, notice now I have a lot more groups because now we're sorting by width and material. So that's how the sorting works, and you can see that it's a very important concept to understand. It's not overly complicated, but it isn't obvious just upon casual observation. So that's how the sorting works and why it has to be there. This way you can download a cut list that has many different material types, and you can, since we sort the material cut list into groups, you can choose which one you want to work on. Now this can work other ways too. You can sort by more than just material. For example, suppose job number was one of the fields we have to work with. You could sort by material and job number and only run parts that are of a certain material type and from a certain job. That way you could download a cut list that had multiple jobs and multiple materials, and initially you could just sort by material and width, for example, and you'd lump all the like material, parts with like material from multiple jobs into one group. Now that's how you're going to get the best yield, but one of those jobs may become hot and you want to get it out right away. So you could just quickly go and change the sorting to sort by material, width, and job number, and then you would have the 4/4 red oak 2-inch wide of a certain job number would be separated from the 4/4 red oak 2-inch wide from another job number. So then you could choose the parts that go to the job number that you need to get out right away and get all those cut, and then switch the sorting back so that you could again get your better yield. So this is a powerful part of the software. Now, so now that we've got our sorting set up correctly, another setting that has to be set just upon initial setup is how we want the grid to be displayed, and that is done by the configure button. So this is fairly straightforward. Basically there's a column that says show in grid and a column that says grid label. So this shows, this under grid label, those are the fields that exist in the cut list that I opened. So notice, this one only has sequence number is something that we generate, quantity, material, width, thickness, part, length, room, cabinet. This only has 7 fields. 8. There's a user field 2. Well, no, user field 2 is not part of this. It's just checked from a previous demo I was doing. So we don't want user field 2 to be displayed, so I'm going to uncheck show in grid. Maybe we do want room cabinet. We don't care about thickness because it's part of the material. We probably want quantity, material, width, and all these. So I've changed it just a little bit. I'm going to click Save Changes. And now you can see we have the room cabinet. That user field column is gone. And so that's how you control what is displayed in the grid. The other thing in this configure screen, I'm in the sorting, configure, are some fields over here. Bar length, DB name. I'm going to talk about that a little bit later when I open an aluminum, a cut list that is tailored for aluminum users. Now this order by, you may want to, what this does is controls how the parts in a certain group, when they're displayed on the grid, the main AutoList screen, this controls how those parts are ordered within that group as they're being displayed on the grid. Usually people want to arrange them by length, either ascending or descending. Now right now it's descending, so I'm going to just go back and we'll see, look at length. So see, the longest ones are at the top of the list, and as we scroll down they keep getting shorter and shorter. So if I go back to settings and configure and change this to ascending, save the changes, now the parts are arranged from length shortest to longest. And so that's what the order by field does. there's also a field here called Profile Diagram DB Name. This is an interesting feature. We can display a picture based on a picture file that you place in a folder, and if you name those files so that they match a certain text string that would appear in the cut list, then it displays that picture. So usually this is for displaying material type or a profile number when you're doing aluminum. So for example, profile diagram database name. Now DB name means we look in this column. It's labeled DB name, which the labels in this are slightly different in some cases than the grid labels. This is because what we call material you may like to call part number, in which case this would say part number instead of material. And you can see user field 1 here is room cabinet. So that's DB names can be slightly different than the grid label names. So what we want to, if we wanted to display a picture of the material type, then we would choose this material, and in this case the DB name is the same as the grid label. So I'm going to go over here and choose material, and then I'm going, the file extension, this is what kind of file you're going to create. Usually it's a JPEG, but it might be a bitmap or a GIF, and so on. So if we choose JPEG, and I save the changes, then what this would do is, in this box here that says file not found, if we had a JPEG that was named 4/4 red oak, exactly the way it's shown here, then that picture would be displayed in this box, and it also shows up in the grouping list right here. So that can help, not so much with wood guys, but with aluminum where you have a profile, a certain profile, it can be really handy. Okay, so how do you use it? We've kind of gone through the basic settings that you have to do in the setup screen. There are also some more settings here that I'll talk about more in depth later, but let's just use the AutoList a little bit. So the way it works is we've opened up our cut list and we've chosen which group we're going to run, and now we're ready to actually cut some parts. So the first thing to do, now I'm going to go through the scenario if you're cutting hardwoods. Using the AutoList for cutting hardwoods that are random length and have defects, you would put the AutoList in stop mode. So you can switch to pusher mode, and you can do this back and forth throughout. Usually you wouldn't, but you can. So I'm in stop mode. So in stop mode, we're going to use the RazorGage positioner as a stop. So what you would do is you would bring your material, let's say our stop is on the left. So you'd feed your material in from the right and make your trim cut. And you do that by eye. You just look to see where you want to cut, make the trim, and you trim off the bad material at the beginning of the stick. So now what we want to do is tell the software how much clear material you have to work with. So usually you would mount a ruler on the infeed side opposite the positioner, and you would look down and look at that ruler and say, okay, I have 66 inches of clear material to work with. So you click enter length, enter 66, and the RazorGage AutoList software immediately creates an optimized solution, and the RazorGage moves to the first position in this optimized solution. In this case it'd be 18 inches. So you can see it found an 18-inch piece and a 48-inch piece. So that is 66 inches exactly. And so it did a nice job of optimizing there. So like I said, the RazorGage by now has moved to this first position, so you would push the material against the stop and cycle your saw. Now if you have a tool safe sensor and you check this automatic part cut checkbox, then when you cycle the saw, the software will cross off this and go to the next line automatically, and the RazorGage will move to that position. If you do not have a tool safe sensor, or you do but you don't have this checked, then you have to click part cut after you cycle the saw, and then the RazorGage moves to this position. And so it would move to this 48-inch position. You would get rid of your 18-inch piece and put it where it needs to be, then move the material against the stop to cut this 48, cycle the saw, click part cut, and it crossed those parts off the list and returns to the main list. Now in this cut list that I've chosen here, all the quantities I believe are 1. So if we scroll down, we should be able to find, there's one, there's our 18-inch part. See, it crossed it off the list, and we should see the other one in here. There it is, right there. 48-inch piece. So as you cut parts out of the cut list, they get crossed off as soon as the quantity reaches 0. If these quantities, if they had quantities that were greater than 0, then it would have decremented from 3 to 2 or 2 to 1. I'll demonstrate that right here. I'll just bring this one back to life. When I click on it, it says quantity is at 0, press OK to add 1 to the quantity and move to the position. The reason we do that now, this is kind of a new feature, is so that when you touch a line item, the RazorGage doesn't just move and surprise you. Here you have a little bit of warning. So you press OK and the RazorGage will move there, and we brought the quantity from 0 to 1, and so now this part has been brought back alive and it's not crossed out anymore. You can also add quantity this way by just clicking quantity plus. Now as you saw when I clicked on a line item that had been crossed off, it came up with a message that said, do you want, press OK to move to this position and increase the quantity by 1. That brings us to another feature of the RazorGage that's very useful, is that when you click on a line item in stop mode, the RazorGage moves to that position. You don't have to punch in any kind of a number. So you can run this whole list that way if you want. You don't have to optimize. You can just open up the list and touch on a line item, cut the part, press part cut, or if you have a tool safe sensor, it'll do it by itself, and it crosses it off and jumps to the next one, and the RazorGage moves to that position automatically. So that's useful if you can be optimizing and then you see a particular color or grain pattern that you know that you want to make a certain part from that material. Then you can just find that part in the list, click the line item, the RazorGage moves to that position, you cut the part and it crosses it off. So it's very useful and flexible. So that's the essence of how the RazorGage AutoList software works. You open a list, choose a group, enter the amount of clear span you have, let's say 24 this time, and it found a 24-inch piece to cut out of that 24-inch clear length of clear material. And you cycle the saw and or hit part cut, and that part gets crossed off the list. Now eventually all these will be crossed off. Now when an entire group gets crossed off, in other words you've cut everything in the group, then this actual group will get crossed off in this grouping list. So that's how you can tell which groups are done. They'll be crossed out here. So that is essentially how you use the RazorGage when using it for hardwood. So now I'm going to open a cut list that would be more typical for aluminum. So I'm going to click Open File. Now I'm going to go back here and find okay, again, here are the groups. Now you can see now the headings have changed because the headings are saved in the cut list. So here is profile number and width and length. Now here again we are still sorting by basically material type, because profile number is really material type, and we're sorting by width. But with aluminum it doesn't make any sense to sort by width. All we need to do is sort by profile number and maybe color if that's one of the fields. So I'm going to go ahead and select this, and I'm going to go to settings, and first thing I'm going to do is correct the sorting. We don't want to sort by width. Now notice there is a color field, so we do want to sort by color, because again we don't want to have red and blue parts all mixed together. We want the red parts together and the blue parts together. Okay, so now let's look at our grouping list. Now we are only sorting by profile number and color, and you can see the length. The length column, just so that you know, is the total number of inches required to cut all the parts in this group that we've chosen. It's 670 on the first group, 570 in the next group. This helps you determine how much material to bring to the saw before you start cutting it up. Okay, so I'm going to choose this first group, and here are the fields that we've got displayed. Now, since this is a different cut list, we may want to configure it differently. We don't want to display width anymore. We don't want to display thickness. We do want to display part description and length. Elevation, that is a term used in the glass industry that is often displayed. Job name and color. I think that's all we want to display. Now, I'm going to talk about this later. We still may want to sort by length or order by length ascending. Our profile diagram DB name will still be material, because now here's an example. Since this customer refers to the material type by profile number, this heading has been changed, but the database name of that field is still material, and that's why we still choose material under profile diagram DB name, and then we'll leave the extension alone. So again, if we had a JPEG named FG-2122, it would show up in this file not found box. Okay, now here we are not working around defects, and with aluminum we'd probably want to use it as a pusher. So I'm going to switch to pusher mode, and I'm going to go to settings right away. Trim at start. Well, first of all, I'm going to talk about this optimization. Optimize on enter length, we always want that checked. Use first fit method. Now this determines the algorithm used when optimizing. If this first fit method is checked, that means it's going to look for the longest part that'll fit in a clear span. With wood, that's a good thing, because you want to take advantage of long clear spans. If you're doing aluminum, you may not want to use this. You may want to use what we call exhaustive enumeration, where it looks at 10,000 combinations, or as many as you put in this value. It usually 10,000 is enough. We've never had to make it more than that. But it looks at all those different combinations and finds the best one. So for aluminum or anything where you don't have defects, then you may want to uncheck this box and use exhaustive enumeration. When we're using it as a pusher, we want to pay attention to trim at start. Maybe we don't want to trim an inch since we've got aluminum. Maybe we only want to trim 1/8 of an inch. And at the end, maybe we only want 1/8. The clamp switchover applies to an auto pusher system where we switch the clamp. We have 2 clamps on the front that are clamping the front of the material, and we only clamp one at a time, and when it gets close to the end we switch over to the outgoing clamp so that the incoming clamp doesn't hit the pusher as the pusher approaches the blade. And this is the distance at which that clamp switchover takes place. I'm going to leave that alone. Load out offset. So when we are going to load out, so we can load a new board, this load out offset tells us how far past the bar length we want to go. So if the bar length is 20 feet and this is 5 inches, then it's going to be 245 inches that we go out to the load position. You can change that depending on how much room you need. First move speed, this is how fast we push it in on the first move, because we come in slow to position the part for the first clamping sequence, and then from then on we'll go at the normal system speed. But this sets the speed of that first move. And then clamp offset, this is when you are using a saw that has front clamps, but we aren't controlling them necessarily, or they don't have the switchover function like our auto pusher does. In this instance, you wouldn't want the pusher to go further than where the clamp is, or else the clamp may hit the pusher. So you can set the distance that the clamp is from the saw. We don't care about this right now. Curtain wall style. If we had a pre-optimized cut list, which I'm going to demonstrate next, we would check this, and I'll get into that later. Kerf adjustment on the fly. What this is if you've cut several parts and you kind of pause the machine, you can check the parts, and if they're all off by a 64th of an inch, then you can change the kerf on the fly and make that correction without stopping the run. So you can check that to enable it. So those are the main settings that we need. We've already looked at this in our sorting. We'll get into printers a little bit later. So here we are. We're now you can see we're displaying color, job name, elevation, all these fields. So now, how do you run it when you're doing aluminum with a pusher? Again, we're just going to enter length. Now, with aluminum, may we have 20 feet. So we enter that, and it has found the parts that make the best use of that 20-foot piece of material, and it's displayed them here. Here is a graphic description, and up here we have the detail. So we've got 3 parts that are basically 69 inches long, and those are the parts that are going to get cut out of this stick. Now these buttons here in the middle only appear in demo mode. That's so I can simulate what the motion controller would be doing if this PC was hooked up to an actual RazorGage. I'm just running the demo software, so these buttons allow me to simulate a RazorGage. So the first thing you would do, we probably will click automatic part cut, because then we don't have to manually hit a button on the screen. Now that only works if you have a tool safe sensor. The tool safe sensor is a limit switch that detects when the saw is up in the case of a down cutting saw, or down in the case of an up cutting saw. In other words, the saw blade is out of the way, which is that tells us we're free to move, but it also enables us to detect when the saw has cycled. So I'm going to click load out, and I'm going to click the button that simulates that it actually got there, and then I'm going to click move to first position and click the button. Again, you wouldn't be clicking this button if this was hooked up to a RazorGage. So it's gotten to this first position. So that's the trim cut. So if we had, this is where you would manually cycle the saw, or if this was had the auto cycle option, the RazorGage would cycle the saw. But regardless, we need to detect that the saw has cycled. So by clicking this BMI saw cycle button, that would be the if you cycled the saw and we detected the tool safe sensor change state and come back on, then this is the signal we would get. So now we've moved to the next location, and here's the next location. Now you would cycle the saw. Another way, if you don't have tool safe sensor, you'd click saw done, move to next. They both do the same thing. So after you click saw done, move to next, the RazorGage moves to the next position. This says that it has arrived. I can click saw done, move to next, and I can just go through, and now we're done. All 3 parts are cut, and I click done, and the quantities of these parts have been decremented by 1. You can see this one is down to 0, and it got crossed out. So now if you're running aluminum, probably and your first piece of stock was 20 feet, probably the next one is. So you can just click use length instead of enter length. And it's the same process. We load out, and then we move to the first position, and it's just continues through until we cut all the parts out. So that's how to use the RazorGage as a pusher in AutoList mode. When you get done with this group, you can click next group, and it'll bring up the next group. Alright, so we've covered using the AutoList with hardwoods with varying random lengths and defects. We've covered using the AutoList with material that doesn't have any defects, such as aluminum. Now we're going to cover using the AutoList with material that has no defects and where the cut list has already been optimized. If you have optimizing software that takes a cut list that's generated by your design software and then optimizes it and tells you, what material to order based on your orders that you have, then we have to set up the AutoList a little bit differently, because we don't want to re-optimize what has already been optimized. We don't want to screw up the solution that your optimization software has determined to be the way you want it to be. So here's how that works. First, I'm going to open a file that's been pre-optimized, and I'm just going to select that group. Okay, now first thing we have to do is we have to get the sorting right. So I'm going to go to sorting. Now when we're using a pre-optimized cut list, we have to sort by material type and bar number. So I'm going to throw bar number over there. I'm going to get rid of this user field 7. Notice this cut list material is referred to as part number, or profile number for this aluminum is referred to as part number. In the commercial glass industry, aluminum profiles are usually referred to as part numbers. So we're actually sorting by part number and bar number. Now the reason we're doing that is that the optimization software applies parts from the cut list to certain bars or pieces of stock. So piece of stock number 1 is going to have parts A, B, and C on it. Piece of stock number 2, or bar number 2 as we're referring to it here, will have parts C, D, and E, and so on. And so if we sort the cut list by material type and bar number, then only parts in the list that have the same material type and the same bar number get grouped together. Therefore, one group is going to have parts that only exist on one bar. And that way, we can still optimize, but it's just an exercise. We just do it this way so that we don't have to change our software. It's still going to optimize, but it's only going to optimize parts that already are supposed to fit on a certain bar. And so that's how we kind of work around. This way we don't have to have a setting that says, hey, you're downloading to pre-optimized cut list. We just sort it differently. And this also allows our algorithms to work so that the parts that we want to be at the leading edge of the bar are there. Like we may want the short parts at the beginning so that we don't push a bar through a saw and end up with a 6-inch piece at the end that we can't really get a hold of to clamp and cut properly. We'd rather have that 6-inch piece at the beginning where we've got 20 feet to clamp to, and then we just cut the 6 inches off the end. So we rearrange the parts on the bar, but they're the same parts that your optimizing software applied to that bar. And we do it by just this simple change in how we do the sorting. So I'm going to update the stock definition. Okay, when we're doing pre-optimized cut list, now in this case the optimization algorithm doesn't really matter, but these values here in the pusher category, they do matter a lot. Trim at start, trim at end, and clamp offset are all very important. Why? Because your optimization software assumes certain values for these things. If the optimization software that you're using assumes a leading edge trim of 1/8, and instead out at the machine the leading edge trim is set to 1 inch, now we've just taken 7/8 more material out of that bar than what your optimization software thought was there. So if there's an optimized solution that takes up pretty much the entire bar, we're not going to be able to cut it because we're going to trim 1 inch off. So trim at start and trim at end have to be the same or less than the trim values that are in your optimization software. It's very important. Otherwise, we'll say we don't have enough material to cut these parts, and you'll wonder why. Clamp switchover doesn't really matter for this. It isn't different for pre-optimized. Neither is loadout offset or first move speed, but clamp offset matters. Clamp offset, like I said before, is basically like a trailing edge trim. We aren't going to go in any closer than that clamp. So if that's set to 3 or 4 inches, we're not going to go in closer than that. You won't get a trailing edge trim smaller than the clamp offset. So you want to set that to 0. That way, it won't interfere with the cutting solution. None of these checkboxes matter for this. We do want to do set stock length from first bar length in grouping. So since the optimizing software knew what the bar length it wanted to apply parts to, we want to pull that bar length from the cut list. We don't want the operator to enter it, because if he makes a mistake, it'll screw up the whole optimized solution. So we're going to check this box. And what that is going to do is going to pull the stock length from the cut list. So the next thing we have to do is we have to tell the software what field is bar length. So we're going to go to Configure. Here are our fields that this cut list has. Let's just check which ones we want to display. Everything looks okay. We do want to display bar number and length. I'm going to just uncheck all these. Obviously we don't want the user fields that that aren't being used here take up room. So that looks pretty good. Bar length DB name. Okay, this is where you tell the software which field is bar length, so that we can pull bar length from the cut list. And you can see bar length is right here, and the DB name is UF5. DB name is this column. That's the name that our database calls it. These are just grid labels over here. So bar length is user field 5. So we're going to change this to user field 5. We can profile diagram DB name. In this case it is part number, but the DB name is material, so this doesn't change. So I'm going to save the changes, click OK, and click Done. Okay, now notice all the parts in this group now are for bar number 1. So if I click Grouping List, you'll see bar number 1, 2, 3, 4 for part number 9120. Then when 9120 changes to 9121, these are profile numbers. Then we start a new bar number 1, 2, 3, 9128, 1, 2, 9129, 1, 2. So you can see that now we've sorted it. For each of these material types, there are a number of bars from which we're going to cut the parts, and it's sorting correctly. So I'm going to just select that top one. And so here they are. So now everything runs the same way, except you can see the bar length here is 288. Now let's just see it pulled 288 from the cut list and loaded it in here. And now we're going to click just use length. So you can see it just fits in there. You can see why if we had our trim cut set to 1 inch, there probably wouldn't be enough room for these 3 parts to fit. But this is a good indication that we're on the same page as the optimizing software that was used to optimize these parts. So from here it's just the same thing. You load out, move to first position, saw done, move to next, or saw cycled, and we've cut our parts. So now it comes back to the grouping, and you can choose the next bar number 2. And that's how to use the AutoList with a pre-optimized cut list. Okay, so we've covered pretty much all the different ways you can use the AutoList. A couple other things I'm going to talk about quickly. Barcode setup and barcode test are not what you think. We used to have a system of defecting using a barcode reader and a barcode tape. We don't do that anymore, so these are basically useless. Printer labels is something that you will want to know how to do. To print labels with the AutoList software, first you have to say enable printing. Then you choose what kind of a printer you have, paper label printer or inkjet printer. The inkjet printer is only going to be found on our APS, our automatic pusher system. I'm going to focus mainly on the paper label printer. The concepts are the same, though. There are fields in which we populate what we want to be printed. So once you've chosen the kind of printer, like in this case paper label printer, then you go to Labels, and here you can choose the font, the left margin spaces, blank lines. These are blank lines at the top of the label. And then you can print a test label from here. So this will just test to see if your printer is communicating properly, if you've got it set to the default Windows printer, and so on. So basically these are the fields that are available. So you can choose a field like this one. We've chosen file name. You can choose part number, length, and so on. And you can populate these however you want. Now, whatever you choose here for labels is also going to show up on our virtual label. So I'm going to save this and click Done and choose a part, and notice that now suddenly information appears down here in this white box. This is our virtual label area. Even if you're not using a printer, if you have fields selected, you can uncheck this. If you have fields selected, the virtual label still gets populated with information, which is kind of handy. So now when I touch one of these, that material or the information that we chose shows up. So that's the virtual label. So it's pretty straightforward. You just choose the fields that you want to appear. You can put, say you wanted to say length by width. So in that case you might choose length and then put space X here and then put width. That doesn't really apply in this example because we're using aluminum and probably don't care the width, but that's what these boxes. You can put all kinds of text, whatever you want, in these blank boxes in between the fields. You can also change the font size of the virtual label. See if I bump that up. Now this is bigger. Okay, the other thing about the labels is you may notice that it says barcodes. So we can print a label that has both text and barcode. And barcodes is, you can set which fields you want to be barcode. You can choose up to 2, and you can choose the XY position on the label where these fields are going to be and what the font is. So what you do is, in the text labels, let's say you're going to put the barcode fields over here on the right side. So then you wouldn't put anything. You'd leave this one empty, maybe this one empty, and you would populate these ones on the left with the information that you want to use for with the text, and then you would position your barcodes over here to the right. So in barcodes you might say that you want it positioned 1 inch from the left side and 1 inch from the top. So that is all there is to the barcode, and you can still print a test label. Okay, so I've covered just about all the features of the AutoList and all the different ways you can use it. I appreciate you listening to this video. I know it's lengthy. Hope you feel like it's worth it. If you have questions, give us a call at 515-232-3188. If you have this video, you've probably already been on our website, but if not, our website is www.razorgage.com. That's RazorGage. Again, thanks for listening, and we appreciate your interest.